Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials, and my name is Sir Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be discussing speed. We shall be discussing speed, velocity, and acceleration. All right, we shall be discussing speed, velocity, and what? Acceleration. Now, what is the meaning of speed? All right, speed means change in distance per time, right? It means what? Change in distance with respect to what? Time. And it is what? A scalar quantity. But velocity is what? A vector quantity. Now, what is the meaning of velocity? Velocity means the change in displacement. It is a change in displacement with respect to what? Time. It is the change in displacement per unit time or with respect to what? Time. Now, velocity is measured using an instrument called velometer. Then speed is measured using what? Speedometer. Speedometer is that instrument that is used to measure what? Speed. While velometer is that instrument used to measure velocity. Take note of that. They will now have what? Acceleration. Acceleration means what? Change in velocity. It means change in velocity with respect to what? Time. Alright. Acceleration, velocity are both vectors, are both vector quantity, but speed is what? A scalar quantity. Speed and velocity, they have the same unit, which is what? Meter per second, meter per what? Second. The differences are one, speed is denoted using S, and velocity is denoted using what? V. Speed is measured using what? Speedometer. Velocity is measured using what? Velometer. Okay. Then it is a scalar quantity. This one is what? A vector quantity. So these are the differences between speed and what? Velocity. Now please, the change in velocity per unit time is called what? Acceleration. Then the change in displacement or distance per unit time is what? Velocity. While the change in distance is over, and with respect to time is what? Speed. Take note of that. There's what we call instantaneous velocity. Instantaneous velocity or speed means the actual speed or velocity at a given point in time. Instantaneous velocity means what? The actual speed. It is the actual speed of velocity at a point in what? Time. At a point in time. Take note of that. We also have what? Instantaneous what? Acceleration. Instantaneous acceleration means what? It is the actual displacement, or it is actual change in velocity or the actual acceleration at a given point in what? Time. That is the meaning of what? Instantaneous acceleration. Now please take note of this. The distance traveled to a specific direction is called what? Displacement. Displacement is the distance traveled to a specific or what? A specified direction. Displacement is the distance traveled to a specific or specified direction. Please take note of that, and it is what? A vector quantity. Now, during the movements of an object, all right, please, when an object moves with respect to 2 points along the x and y axis, when an object moves with respect to 2 points along the x and y axis, all right, you say, of course, this is the y axis, and this one, this is the x axis. At x1, you have what? Y1. At y2, you have what? X2. All right, and here you have a slope. Now this slope, I'll just say a, b. All right, for me to calculate this slope is given as what? Change in y over what? Change in what? X. Which means that y2 minus y1, y2 minus y1 over x2 minus what? X1. So that is it. Y2 minus y1 over x2 minus what? X1, which is what? Slope. Slope along AB. You see, change in y over what? Change in x. Then equals, there's change now, like first between y2, y1 and x2, x1. That is for that along a velocity time. You know, this is a velocity time graph, right? Velocity time graph. All right. So the next thing is the displacement of an object along the x and y axis. All right. If an object y, excuse me. Good. Oh, please, I'm sorry about that. Okay, it was landlord that called me. Okay, back to business. I said, for example, now if an object y, that is a body y, move with a displacement of xn, all right, differentiate. Now, if differentiating this problem, I'll say dy, let me just do it here, please. I'll say dy over dx equals, now this n that is, which is the power, is coming to the back of x, which means that n times x, I'll have what? Nx, and there's always what? Minus 1. I have n minus what? 1. So the differentiation of x raised to power n is simply nx raised to power what? N minus what? 1. Take note of that. For example, if an object moves with a displacement of 3x3, or that is 3t3 plus 4t2 plus 5t plus 2. If an object moves with displacement of this along the x or y axis, all right, find the velocity. B, find the acceleration. Find the velocity and find the acceleration when t is equals what? 2 seconds. All right, an object y moves with the displacement of along the x or y axis. Calculate the velocity acceleration when t is equals what? 2 seconds. Now listen and listen very well. To calculate for velocity, we'll differentiate this problem just once. But to calculate for the acceleration, we'll differentiate this idiot 2 times. To calculate for velocity, we'll differentiate this one once, but to calculate for the acceleration, we'll differentiate this entity 2 times. Which means I'll now say dy over dx equals, don't forget the rule I gave us. This 2 is coming to the back. It becomes 3 times 3, I have what? 9t. Now there's minus what? 1. I have what? 9t squared plus, this 2 is coming over, it becomes what? 8t. Then don't forget minus 1. That is 8t what? 1. But there's going to write 1. So leave it like that. Then plus 1 minus 1, I have what? 0. According to the law of indices, anything raised to power 0 is what? 1. So 5 times 1 is what? 5. So this single figure is to be what? Neglected. It does not what? Follow. But it's that t is equals what? 2. Which means that 9 open bracket 2 raised to power 2 plus 8 open brackets 2 plus what? 5. Alright, plus 5. It therefore means that 2 times 2, 4, right? So 4 times 9 is what? 36 plus 2 times this is what? 16 plus what? 5. Right? 2 times 8 is what? 16. Then plus 5. This plus this is 21, right? 21 plus 36, that should be 57. 7 meter per what second. This is what the velocity. Right, the velocity of this body is what 57 meter per what second. We just differentiated once, okay, to get this. Now to calculate for the acceleration, we have to differentiate 2 times. To calculate for the acceleration, we have to differentiate 2 times. Already this one has been differentiated as this. So for me to calculate for the acceleration, I'll differentiate this one again. So now I have that. Don't forget, the y over the x equals, this 2 is multiplying this, I'll now be having what, 18t, then plus, don't forget, there's always what, 2 minus 1, so I would have written 1, but there's no need to write this 1, so there's 1 minus 1, right? So we now have, this one is to be neglected as well, so 1 minus 1 is what, 0, 3 raised by 0 is what, 1, so 8 times 1 is what, 8, alright, then equals 8 open bracket 2 plus what, 8, don't forget t is what, 2, which means that 18 times 2 is what, 36, 36 plus 8, I'll have 44 meter per second what, squared. This is what, the acceleration, and this one is what, the velocity. To calculate for the velocity, you differentiate once, but to calculate for the acceleration, you differentiate 2 times, okay? Take note of that. So that is for that. I believe is understood enough. Now, again, no objects move differently. Some objects move with constant speed or velocity. Some objects move with uniform acceleration, while some move with what? That is, some decelerate or they retard. Now, look at it here. Velocity time graph. If an object moves with a constant velocity, it is shown like this. Don't forget, this is your v, which is in meter per second, and this is your time, which is what? Which is in second. So this one is called what? Constant speed. Look at it. This is straight line, constant speed, constant speed. All right. This graph, this velocity time graph shows what? Constant speed. Now, if an object moves like this 0, point of rest, t second, velocity meter per second. You can see now that the objects moved from rest. You see uniform what? Uniform acceleration. Uniform what? Acceleration. This graph shows what? Uniform acceleration. It's moving from what? Rest. And on that graph, which is the last one. Now, what did you observe in this graph? Don't forget, c is a second and v meter per second. What will you observe in this graph? You observe that the object is coming down, is what? Decelerating or retarding. You see, this one is what? Deceleration or retardation. Deceleration, uniform acceleration, constant what? Velocity. Please do not forget that. As a YX student, as a JAMBite, as a NECO student, as a GC candidate, nursing candidate, NAPTEP, take note of everything. This constant speed, uniform acceleration, and what? Deceleration or retardation. Take note of that. Okay, now let me put a question on the board. Okay. 1. A body accelerates at 20 meter per second squared in 20 minutes. Calculate the distance. Calculate distance in kilometers. calculate distance in kilometers, what will I do? Now, we have three formula. We have S equals ut plus half at squared. We have V equals what? U equals U plus at. Alright, we also have V squared is equals what? U squared plus 2GS. Okay, 2AS now. Now looking at the question that we have, two things are to be related. One, acceleration. Two, time. And three, what? Distance. Now looking at what we have here, this one only shows velocity, acceleration, and what? Distance. This one shows velocity, acceleration, and what? Time. But this one shows distance, acceleration, and what? Time. Acceleration, distance, and what? Time. So which means we have to use this formula. Now, U is always 0. Hope it's recording. Yeah. U is always 0. It means that 0 times t is what? 0. So this one is to be neglected. I have that x equals what? 1 over 2 times, acceleration of the equation is what? 20 times, the seconds was given in minutes, so we have to convert to what? Seconds. In doing that, we are going to be saying 20 times 60. So you say 20 times what? 60. Alright, 20 times 60, which is going to be 2 times 6 is what? 1200, which is what? 1,200. 1,200 squared. Jesus. 1,200 squared. So which means 2 here, 1, 2 into 20 is what? 10. It therefore means that S is equals 10 times 1,200 times 1,200. Jesus. I have 4, 4, 1, 2, 3, 4. Alright, 440,000. Then times 10. I'm going to be having distance as please let's calculate in meter. So if we are calculating in kilometer, it means that we have to multiply this large number with 1,000. No, it will be too big. Or should I do it? Let me do it. Kilometer. Let me just do it. Since I've written it already. So 10 times 440,000 is same thing as what? 4, 4, 1, 2, 3, 4, 5. They said in kilometers. So we have to multiply by 1,000. If you are converting from meter to kilometer, what will you do? You will have to multiply by what? 1,000. So S now is equals 4, 4, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, I'll prefer to express this in standard form. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 4.4 times 10 raised by what? 9 kilometers. Alright, so that is the answer. So we have got the answer. 20 minutes we have to convert to seconds, which means that 20 times what? 60. We have 1,200. Then you have 2 into this, you have 10. So 12, that's 1,200 squared. I have what? 44,000. Do it, you have what? 4.4 times 10 by what? 9 in kilometers. All right. So that is for that. Now the next question. If a body accelerates, all right? If a body accelerates at 4 meters per second squared in 20 minutes, or in 20 seconds rather, calculate the distance traveled. Calculate distance traveled. Why are these markers not writing well? I refilled them just now. Calculate the distance traveled in the last A 1 second, B let me say 17th what second. Now don't forget your formula. S is equals what? Half AT squared. Now a body accelerates at 4 meters per second squared in 20 seconds. Calculate the distance traveled in the last 1 second, 17th second. It is very simple. Whenever you get the word last second, the seconds given in the question is what? 20. So you say 20 you say 20 minus what? 19. The last 1 second, because 1 plus this 19, I will have what? 20. So whenever you hear the word last second, it is this minus this. That is 20 minus the number before 20, which is what? 19. Therefore, now I have that S equals 1 over 2. Solution from the question is what? 4 times 20 squared minus 19 squared. Alright, 2 here, 2. So now that S equals 2 open brackets 400 minus 19 times 19. 361. 36 what? 1. So now that S equals 2 open brackets, alright? Do not say 20 minus 19 all squared. No, you will get it wrong. You have to square it differently because T is having what? 2 as a power. So 400 minus this, I'll have 400 minus, I'll have 39. Right? I think that is actually correct. We have 39. 39, yeah. 39. So, which means that S is equals 2 times 39. That should be 78 meters. Which means that the distance traveled in the last 1 second is what? 78 meters. 78 what? Meters. Now, let us now calculate the distance traveled in the 17th second. The distance traveled in the 17th second. Look at it. Acceleration is 4, you square. So 2 into 4, you have 2. You have 2 here. So for 20 times 20 is 400. So 19 times 19 is what? 36 what? 1. So 400 minus this is this idiot. Alright. So 2 times this idiot, you have what? 78 meters. So the distance traveled in the last 1 second is what? 78 meters. Take note of that. Now B, they say we should calculate the distance traveled in the 17th second, which means that we are going to be saying 17 minus the number before it, which is what? 16. All right, don't forget S is equals 1 over 2 times 4 times 72, that is 72 minus what? 16, 2, which means that 17 times 17 equals, now S is equals 2 here 1, 2 here 2. So 2 open brackets, 289 minus 16 times 16, 256. Alright, so distance is equals 289 minus 256. 289 minus 256 equals 33. So 2 times 33, S is equals what? 66 meters. So which means that the distance traveled in the last the distance traveled in the 17th second is called what? Is 66 what? Meters. But the one traveled in the last 1 second, I think we had it to be 57. I don't know again. 57 what? I don't know. Just check. 57 whatever. Okay, so that is for that. I believe is understood. All right, it is very, very clear. Just follow it step by step. Okay, now we have a question about, or let me give us this question before I conclude. because I'm concluding using this question. Now, number 2, I don't know the number, any number at all. Okay. Oh God, what is wrong with all these markers now? I refilled them just now. A body accelerates along the x and okay, I'll accelerate along 2 points. Along what? 2 points. I have 5, 10, and 15, 20 along the velocity time graph. Along velocity what? Time graph. Calculate the slope or acceleration. All right. Now, they said a body accelerates along 2 points, 5, 10, and 15 what? 20 along the velocity time graph. Calculate the slope or acceleration. Now you say the first point you say equals this 5. Okay, where is the first one? Okay, I have what? 5, 10. Then I have what? 15, 20. Now the first loop is 5, 15. The first loop is what? 5, 15, which is x1 and y1. Then the second point is equals what? 10 and 20, which are going to be what? x2 and y2. Now, when I was explaining something, I drew something like this. At x1, I have what? 5. At y1, I have what? 15. Right? This x1 and this what? y1. Then at y2, I have what? 20. Let me distance it a bit. y1, y2. Right? Because this is the y-axis and this is what? The x-axis. Now at x1 you have y1, then at y2 you have what? x2, which is what? 10. Now here is the slope. So I can make here A and this place what? B. Now to calculate for the slope, alright, I told us is what? Change in y over what? Change in what? X. Which means that this minus this, which means y2 minus what? y1 over x2 minus what? x1. Now to calculate for this, it becomes 20 minus this. 20 minus this is what? 5, right? 5. Then this minus this is what? 5. Therefore, you have it to be what? 1 meter per what? Second squared. So that is the answer. So just plot out your graph at y1. So which means from this you have to relate it like this. That is, this first is to the first, then this second is to the second one as shown here. 20, that is 15, 5. Is that not correct? 15, is it 15? Okay, 15, 5 now. Then 10, 20. 10, 20. All right. To just plot out your graph, you know how to apply for the what? The slope. So we now have it to be what? Because 20, 20 minus 15 is 5. 10 minus this is what? 5. So 5 divided by 5 is what? 1. So the answer is what? 1 meter per second square. Hope it's recording. Yeah, it's recording. So the answer is what? 1 meter per second squared. Now, you have Oga at the top on the board. So we have established this one already. So let's round off with this very one. Okay. So, it's good there are certain topics that are challenging to us, but if we should give it our time, they will succumb, all right? They become what? Our subject. So, from what we've done so far, do well to play the video over and over again for a better understanding. Okay. Let me refill this marker, please. Excuse me, sorry. I'm sorry for wasting your precious time. Work. All right. Thank you for your permission. Thank you for your permission. Even if you don't permit me, I'll do one. Must you permit me? Okay, sorry. We're not gonna joke with you now. Okay, now let's round up with this. Now, this kind of question, you can see how long it is. The first thing you do is to read the question for a proper understanding. A car runs at a constant speed of 15 meters per second for 300 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. This speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph and therefore calculate the acceleration, the total distance traveled, and the average speed. Now, the first keyword here is what? Constant speed. The body moves with constant speed, which means for we to construct our graph, don't forget what I said earlier. Yeah. Now, the body moved with what? Constant speed. Constant. Did you see that? This is a constant speed. All right. At what velocity? 15 meters per second. 15 meters per second, right? Okay, for how many seconds? 300 seconds. 300. Don't forget, this is your velocity and this is your time. Now, and then accelerates. Good. It has now accelerated. And then accelerates uniformly, as from this place, at a speed of what? 25 meters per second. 25 meter per second over a period of what? 20 seconds, which means plus 20, I have 320. This speed is maintained for 300 seconds, which means that 300 plus this idiot, I have what? 620. 620 before the car is brought to rest with a uniform deceleration in 30 seconds, which means 30 plus this 620, I have what? 650. 650. Don't forget this your time. Now, food is what? Ready. Let me label it as A, B, C, D, E. Okay, let me make here, of course, this is your O. Let me make this place, okay. Let me make here J, M, U. All right, MU. All right, so it said calculate the acceleration. Now, where did the objects start to accelerate? This point, all right? This was the point of what? Acceleration. Now, to do that, now acceleration is equals BD, all right? BD over what? Look at it, it's at this point over 320 minus, that is, I'll now say U or mu, that is MU, right? Is that not correct? BD MU, all right? So I'll have 25 minus 15 over 320 minus 300, 320 minus what? 300. All right, so acceleration therefore is equals what? This, okay, which means 25 minus 15 is what? 10 over this minus this is what? 20, and I have what? 0.5 meter per second what squared. This is what? The acceleration. Now this is what? A. Now the total distance traveled. The total distance traveled. Listen and listen very well. I'm about to do it now. Total distance. Now what shape is found here? This is what? A rectangle. Now you know that the area of a rectangle is actually what? Length times what? Breadth. This is the length and this is what? The breadth. This is the length and this is the breadth. So I will say if here is 15, it means that here is also 15, right? If here is, because here to here is 300, if here is 300, it means that here is also what? 300. I can see that AB times BM, right? Like AB times BM plus, now this is what? A trapezium. 1 over 2, open brackets, this plus this, and this is what? The distance. All right, which means 15, that's 25 plus 15, and the height, if I should construct this again, if I like something like this, here I will be having 320, I'll be having what? 300. Now this is what? The height. So now you have 300 and you have what? 320. So 320 minus 300, I have what? 20. So that is what you have here. So it means that we are not true. Then plus, now you have another rectangle here, true or false? This is what? Another rectangle. This is another rectangle, right? So which means that, okay, let me label this place Y. All right, from this is my breadth and this is what? My length. So the length from here to here is what? 25. So it means that 25 times this minus this is 300. That is 25 minus times what? 300 plus. Now this is what? A triangle. The area of a triangle is what? Half base times what? Height. Half base times what? Height. That is half. The base now is this minus this. Alright, this minus this, I have 30 times 30. I'll rub off this one, please, since we've gotten here already. 1 over 2 times 30 times, then the height is what? 25. Don't you see it's very clear? Now, this part is a rectangle, which means that length times what? Breadth. Length times breadth. The length is 300, then times 15. You have this. Then this is a trapezium, that is okay, plus 15. Then plus this is another square, that is length, which is 25 times breadth. That is this minus this, I'll have what? This, right? Then this is what? A triangle. This is a triangle. It means that triangle is the area of triangle is what? Half base times height. This is the base. 650 minus what? 620. I will have 30. The times the height, which is what? 25. Okay, I would have used the alphabet all through since I've been doing like, okay, fine. Let us just continue. Total distance now is equals AB is what? 300 times what? 15, right? Plus, now it's time, so what will I, what am I doing? It's like I've made a mistake. Wait, times height, which is 20, plus yes, plus 300 times 25. All right, 300 times 25 plus 1 over 2 times. All right, we must be very, very careful. Now, so you say 25 plus 15 equals 40. 40 times 20, I have what? 800. So 800 divided by 2, I have what? 400. So everything here is what? 400. So let me also do this one. Then 300. Let me just continue like that first. Plus this times this. That should be 7500. 25 times 300 equals good 7500 plus 2 here 1, 2 here 15. So 15 times 25, 15 times 25. We have 375. 375. So total distance is equals 300 times 15 equals 4500 plus 400 plus 7500 plus 375. So which means that 4500 plus 400 plus 7500 plus 375 equals, so total distance now is equals what? 12775 meter. So just follow it step by step. You have this. Now this is what? B. The total distance. Just follow it the way I did it. Now, but the average speed of this objects of this car is simple. All right, the average speed. Where is it? Marker now. Wait. The average speed. Don't forget 650 here is always your time. The average speed, which is C. Average speed is definitely total distance traveled. Total distance traveled over total time taken. Total time what? Taken. Total distance traveled, we had what? 12775. Total time taken is what? 650. So which means that 12775 divided by 650, I'll have 19.654 approximately 654 approximately second. Okay, average speed. Okay. Meter per what? Second. It is very, very simple. It is very, very simple. Just follow it step by step. All right. So this one is quite easy. This acceleration is easy. But in terms of this total distance, you must be careful. Follow this a rectangle, this a trapezium, this another rectangle, and this one a triangle. Just follow it step by step. So at this point, we'll call it a day. Should we call it a day, or I should give you something to do? Okay, let me give you an assignment. Do this for me. Okay, let me give you something to do. So you used to relax. All right, you used to chill up. All right, so Everybody must do it. Oh, everybody must do it. A body accelerates from rest with a velocity, the velocity of 10 meters per second in 20 seconds. In 20 seconds. It maintains same speed for another 30 seconds. For another 30 seconds. It was brought, okay, it decelerates for 50 seconds. Calculate A acceleration, B distance traveled, C deceleration, and D average speed. So this is what you have to do all by yourself. Please, after solving everything, please put the answer on the comment section. I believe you learned something today. If at all, please, as you have watched, don't forget to subscribe to my YouTube channel. More interesting videos are yet to be uploaded on physics, because physics is one of the most interesting subjects in the world of science. Don't forget, my name remains Tutor Joseph. Please subscribe. Do have a wonderful day.